Hello everybody. For those of you coming to the channel looking for a new model railroad video, unfortunately this one's not going to be about model railroads or anything model train related today. This is actually a repair video, and I'm going to go into detail on that in a second, but so for those of you looking for model railroading, hopefully next video. You can stick around for this one if you want, but it's going to be about repairing a PC mouse and not really necessarily about anything train related. It is soldering related, so if you want to learn a little bit about soldering or even just mouse repair, stick around. For those of you who are here for repairing a Logitech G700 gaming mouse, you've come to the right place. For those of you who have them, I personally love this mouse. This mouse has been with me for, I don't know, 5, 6, 7 years. I don't know. It's really, in my opinion, hard to find a replacement mouse that kind of fits all the needs. I use this for Warcraft all the time. Being able to map all the thumb buttons and index finger buttons and everything is, oh, I just love it. It's great for first-person shooters as well. Maybe not the most high DPS or DPI laser compared to some of the other mice out there, but frankly, I'm old and I don't really first-person shoot anymore because I just get killed by everybody. But these mice are hard to come by. They're out of production. Like I said, I haven't found a replacement that's been a suitable alternative to it with the number of buttons and everything that goes with it. I know that there's other ones out there. Razer makes some good ones, and I'm sure they're out there. But like, I really like this one. The weight, the feel. I have big mitts, so this is a good size mouse. So it's about $125 from what I found to get a new one because they're out of production, or you can repair them. Because one of the issues that these have developed, which is probably why you searched on this, is that you get the double click, which is due to the spring debouncing inside the button. And you can bend the springs back, and I did that a couple times with this one. It doesn't last real long. Once those spring contacts begin to weaken, it comes back. So today I am going to disassemble this using a guide on iFixit, which I'll link in the show notes below. I'm just going to follow that guide, but I thought a video to show you how it's done, especially with the soldering required, would be good in case you want to tackle this yourself. I might ruin a mouse it's functional. Crossing my fingers that I don't. So here we go. First, some tools of the trade that we're going to need. Solder and some flux. Anytime you do soldering with electronics, you want to make sure that it's a rosin. This is a paste. It comes in a container like this. I use it for a lot of other things, so I have a whole container of it. You can get smaller amounts if this is going to be your only project. This is a lead solder. It flows a lot easier, lower melting temperature. I will caution you, it is lead. And if you do use a lead-based solder, you want to make sure that you either wear gloves or you wash your hands prior to eating anything that is toxic. Solder wick, which we will go into when we need this. This is for removing solder and desoldering the connectors that we have to desolder and the current switches that are in there. I've got a couple tweezers. I don't know that I'll need them, but they're always good to have around. Phillips and flathead, smaller headed screwdrivers, just because, you know, working with small electronics, chances are they're going to be smaller. This is my soldering station. The things you see here, this is a little bit more of an advanced soldering iron. You can get by with an inexpensive Weller 45 watt iron. The disadvantage of those is that they're not temperature controlled. You plug them in, they just heat up, and they'll continue to keep heating up. And when you're working with electronics, too much heat is a bad thing. You can end up lifting copper pads and traces off of the circuit boards with too much heat. The advantage of this one is that it holds the temperature that it needs, and it also temperature senses how hot it should be, and it adjusts the amount of current flowing to the tip and only gets as hot as it needs to be for electronic use, which is really nice. This one also has several different sizes. It's not turned in and it's not turned on, so I can touch it. This is a little bit of a thicker tip, which I'm going to use to desolder things, so it helps to spread the heat out a little bit. For fine work, I also have a fine point tip as well. You can kind of see the differences between the two. This one I would use to solder on smaller components and wires and things. To clean the tip, this is just a wire mesh, and when you get solder on the tip of your iron, you want to clean it off. You stick it in and just drag it across, and this mesh will capture any solder that's on the tip in here. Other alternative to this, if you don't have this, everybody has a sponge around. Wet your sponge down, and you can see, if you look closely, there's little solder balls. Once this is wet, you can drag it across and it'll catch the solder balls on there. It keeps the tip nice and clean. Never want to... Okay, so that's everything that we need in terms of tools. Obviously there's my mouse, and again, I'm using the iFixit guide, which you'll find in the show notes, and I'm following that pretty much as they did it, and you know, so all props go to the user that created it. I would have been kind of flying blind if it wasn't for that guide. So there is a link in the iFixit link to several different buttons that you're going to need, the replacement switches, if you will. I bought these off of eBay for I think $5.99, something like that. There's 10 of them. I bought extra. I'm going to do the right and left mouse buttons right away. I've got it open, might as well go for it. Both exhibit the double click, might as well do them both. Alright, so first things first, pop off the battery cover, take the battery out, drop the mouse. And as you can see, I've peeled these off before, but you can just peel these back, and if you've never done this before, yours will peel off a little bit harder. Be careful when you're working with an X-Acto blade. There's screws under all of these pads, and what I like to do is just got a piece of plastic. We're going to use this. This is an old baby food container, but you can use anything. I'm just going to gently stick them to the top of the baby food container. Alright, under all of these pads you can see that there are screws, so we'll need to remove all of those, and actually this screwdriver is going to be too big. Always good to have a bucket that you can put it in. If you've got a magnetic tray that you can put everything in, that's always good too, because then they won't go anywhere if you tip it over. So 1, 2, 3, 4, 5 of them. Let's see if I got them all. Yep. So the top should just lift off, and there is a 3-pin wire here that goes to 4-pin wire that goes to a connector that goes to the top. It does have a locking tab on it, so sometimes a little bit of an X-Acto, just gently get in there and pry that open. There you go. So it has these 2 locking nubs on it, on the connector, so you just got to pry this back a little bit here. These right here, just pry them back. Now, that's this. We shouldn't need this, so we can set this on the side. Possibly a good opportunity to clean up any of the seals and stuff from years of button use and everything like that. Okay, I'm going to hopefully keep my hands out of the way as I show you these next few parts. In the notes in the iFixit walkthrough, when you first open this up, they suggest to flip this up, and now we are removing this tab here. So here's where a good set of tweezers will come in handy. So you grab that and remove it. Now, you want to make note that this U shape, it kind of looks like a backwards H, is facing down. So when we put this back in later on, we'll want to make sure that we put it back in like so. So we're removing it like that. I'm going to sit this in the screw pin container. And according to this mechanism is supposed to lift out as one piece. It does no. Okay, got ahead of myself a little bit here. The springs are not actually in there. The springs are right here and here. So you're going to want to make sure that we don't lose those. Now, let's see how easy or difficult it is to remove these. Yep. Alright, we're going to put those, so I'm going to remove those. Now, working with model trains, if you watch the beginning of this, I'm used to losing small pieces, but that doesn't mean I really want to find them, because it is a pain in the butt. So these 4 screws need to be removed before we desolder anything. So this piece comes off together, it looks like. So remember the orientation of that. Tab is towards the front of the mouse. Put that in our parts bin. Then the next 2 screws are here and here. We need to free this circuit board up from the base circuit board. And then that's where I got ahead of myself. Then we're going to have to desolder this connector, which connects it to the board below. Okay, so I thought that using the the larger tip was going to make this easier, but actually these pins are pretty small. Now, this solder to me, I don't know for sure, but being that this is a commercial product sold within the last 10 years, chances are this is lead-free solder, or it's a very low lead content. The problem with lead-free solder is it can be very difficult to reflow, which can make it difficult to get your solder braid to wick it up. So contrary to what you would think, it sometimes can be helpful to come in with lead solder and add a little bit of lead to this. And unlike normal, getting the lead out, no pun intended, in this case, I'm just touching these pins and putting a tiny bit of lead back into them. Now, the purpose of the solder braid is to wick the solder to the braid, and you can do this with either a solder sucker or with the solder braid or this solder wick. And all it is just a copper wire woven together to form a braid. And you want to apply the heat to the braid and get the solder to wick up to it. And you kind of want to move quickly. You don't want to linger too long on any one pin, because these will, the more time you spend on each one of these, the better chance you have of lifting a copper pad or a trace or something, and then now you're kind of, for lack of a better term, SOL. So what's helpful here is to have a pair of side cutters. And each time, just trim the end off and dispose of it, and then that way you're always working with the fresh end here. Alright, I want to show you this while I'm doing it, just because I found one of the best ways to do it is actually a way to lay the braid in between all 4 pins and kind of heat them all up at once. It gets the whole area to reflow, and the wick does a really nice job of kind of sucking it all up, so you can see how it removed most of the solder from all there. Then I trim these, just trim the wick up, and come back in and do it again. Okay, so the solder wick works, but sometimes what'll happen is like anything, it's solder kind of gets everywhere, and if it flows well, it flows into everything. And so what happens is that these holes here are plated through, at least they should be, which means that there's solder touching the sides of these pins as well as the top, just not just what you can see, but also internally to these barrels. And so sometimes what you have to do is you kind of just try and rapidly, gently lift up and heat these pads up just briefly, enough to get the solder to reflow on each one of them. And sometimes you can tell that there's some that just are hanging on. There we go. So now these are the two switches that we're going to be replacing. This guy here and this guy here. Now if you notice, they're in different orientations. So you want to make sure that we take note of that and we put the new switches in accordingly. So the same thing we just did for that connector, we're going to do on the switches themselves, which are these 6 pins here and here. Alright, time to desolder these guys. Like I said, I am going to put a little bit of lead solder on these pads. Sometimes what's really helpful is an electronics stand, just a couple alligator clips held on to basically an arm. If you have to work by yourself or don't have anyone to help you, sometimes that can be helpful. Honestly, I think for these the larger tip might have been more useful, but I'm not going to switch it at this point. Alright, so once these are desoldered, out she comes. So there's your bad switch. Oh, so here's really nice. They actually, on the silk screen of the board, they actually put where the button goes. That's really nice of them. That's a good foresight into the assembly on this, which helps their assemblers in the factory. But for our sake, it'll help you repair these as well. So here's the dash indicating where the button itself goes. If you're having trouble getting these out at all, if you just grasp the connector or the switch on this side and you kind of just pinch it a little bit, that'll push your fingers will push against the board, and if you start to heat the pins up a little bit, you can feel it just kind of work its way out, and then out it comes. Okay, you don't need to do this, but because I'm doing for demonstration and putting this and kind of just showing things, I want to make sure that I know which parts are the switches that I took out versus the ones that I'm going to replace. So I put some blue painter's tape on here just to indicate these are the old switches and the bad ones. So here's a new one. It's really hard to say that the click is any better. It feels firmer to me, but it'd be really interesting to see once we get these in what it feels like in terms of click. So now we're going to do the reverse process, but this is where the flux comes into play. And flux is used to clean off electrical contacts to get rid of contaminants, especially oils from your fingers. To avoid that, you can wear gloves. It is recommended that you wear gloves, and that avoids getting oils and things on surfaces that you want to solder to. But flux is also used for that. It gets rid of all contaminants, gives you a nice clean surface to solder with. So I'm going to go ahead and insert these. and they sit in there just right, perfectly. Unfortunately, they are not being held in there by anything, so this could be interesting. Okay, so again, the alligator clip is going to come in handy here. I actually have the alligator clip pinching the board and the switch itself. So this is just a micro brush, but you can use anything to apply the flux. But what you want to do is just take a little bit of flux, and it's a paste. It comes in a liquid form in a squirt bottle sometimes. Just apply a little to either side. The pin is the most important part. The solder pad that we just took off, you know, is pretty clean. So now to solder, you want to just get a little bit on the tip of it, of your soldering iron, and then clean it off. That helps tin the tip a little bit, but it helps create, you know, the tip is hot enough. You don't need a ton of solder, and you just want to get it to flow. So we'll start up here. And that's it. There's a good indication of a nice, good joint. I'm going to do both outside and then come to the inside. There we go. That's all you need. There we go. You don't want to overdo it. These aren't plated through holes, it doesn't appear, so you just need solder on the surface. Okay, so here's a little piece of advice too. Maybe not the most ideal, but if you don't have a set of alligator clips or an electronics stand, but you need to get these soldered back in. As I said, I'm a model railroader. I had a bag of gravel, but a bag of sand, a bag full of flour would work too. But basically anything that can conform to an uneven surface, and you just press it in, and you can tell that now the new button is being supported, and I can quickly and easily just come in here and solder that on, and that button's in place. Alright, well, if you've made it this far, I'd like to say that we're almost there. So let's put this board back onto the main motherboard, I guess. This is kind of a daughter board. Let's put it back on the motherboard. So these two pins here, where the screws end up going in, need to go, it'd help if I'd show that, here and here, and then obviously we need to get these connected back up. So try and come in as straight top down as you can. Hopefully if your solder is cleared out of these holes here, this should just fit right back on, and it does. Perfect. Alright. In terms of flux on these pins, I don't feel you really need to, but we'll go ahead and do it. These should be pretty clean since we just desoldered them. So maybe just a little along the pins here. Just, if nothing else, it'll help the solder flow into place. Good solder practice would also suggest that once you've put flux on, that you do clean it off, and you can do that with just a soft bristle brush. Don't use water or anything like that, obviously. Because this is an acid based and it shouldn't attract too many contaminants, if you were doing this in the real world, if you were assembling this circuit board, they would send it through a wash and remove all the flux and everything. Not as critical at this point. If you have a magnifying glass, at this point I would suggest you use that to inspect to make sure that you haven't bridged any of these pins together. One of the things that we could have done, and maybe should have done prior to starting this, was to see if, using an ohm meter, see if any of these pins were shorted to begin with. If you don't do that beforehand, now if you were to measure them, some of these pins may already be connected. So if you're looking for a short that you created, well, it might be in there intentionally. So that's pointless to check for shorts now. But just a quick magnifying glass, and then checking to make sure that there's no shorts on that connector at all. It'll be really interesting to see what that looks like. Alright, everything looks pretty clean. I don't see any shorts bridging between any of the pins, which there wasn't prior when we first did this. Alright, now we're going in reverse. So let's move our solder station out of the way. We are done soldering. Probably the most nerve-wracking part. Those springs need to go back in those holes, but we're going to do that. Let's do that now. Again, nice pair of tweezers, and cross your fingers. Okay, there's those. And now the assembly here. I was thinking I should clean this up a little bit, but we'll leave it. Okay, you can give it a little click. And the iFixit notes that those springs actually give you the bounce back on this middle click, so you know that it's good if you get that click. And there's the click that engages the, it's actually a mechanical, which is really interesting. And now the U-shaped clip, or this guy here, which if you remember, the reverse H should be that way. So we'll just go ahead, reinsert that. Oop. Reinsert that in there, and that button is reassembled. Perfect. Alright, now for the top side, reconnect this guy. It's keyed, so you can't put it in wrong. You could probably if you forced it, but don't force it. Look for the barbs that are on either side here. Try to avoid pressing the wires in from the top. It's, you know, kind of natural to want to do that, but try and press in from the side. If you press in on the wires, you might bend them and break them. Give a little bit of a tug just to see, make sure that they don't come out. Alright, so this is the, ooh, that's nice. So this is the point where you can do one of two things. You could be dumb like I'm about to be and reassemble everything, including the screws and the feet, and then go test it. Or you could carefully plug in the battery, turn it on, and test it. That's no fun. I'm gonna go right for the gusto. I'm gonna reassemble this thing and see. Well, I ran upstairs real quick, plugged everything into the computer, and actually it worked. I'm really hoping that you had success with this. I hope you found this helpful. All credit to the iFixit guide, which really stepped me through everything. Hopefully this video guide can give you an idea of what it takes. It's really not that bad. Soldering can be intimidating. just learn to work quickly. Don't hold the heat on too long, and overheating actually can be a bad thing with soldering. If you're used to soldering pipes, the copper pipes and stuff like that, a little bit extra heat, not too big a deal. Electronics, a lot more sensitive. You can start to melt the plastic of, like, say, the switches that we're replacing. Like I said, you can lift copper off the circuit board itself. You don't want to do that. But hopefully you give it a crack. I will suggest, if you want to tackle this, you're not sure about soldering, pick up some old electronics that you might have, old hard drives, old sound cards, you know, motherboards that you've got laying around, stuff that you were going to throw out anyway. Desolder some parts off of there. Surface mount parts are going to be really easy. Try some of the through-hole parts. Don't try any of the PCI connectors or you know, ISA connectors or anything. Those are a nightmare. Maybe the 4-pin fan headers, or you know, the headers that go to the power switch or something like that. Those will be a good test for desoldering this kind of stuff, getting it to wick up through. And like I said, if you've got stuff that's been built within the last about 10 years, if you know that it's marked ROHS, R-O-H-S, shows a lead-free symbol on it, then it's using a high tin content solder, a low lead content solder. That stuff doesn't reflow well, and you might want to think about doing what I did and just touch a little bit of lead solder on there to help it flow better, which will help it wick back up to the solder wick. And hopefully that helps you. So I really hope the guide helped. To those that are here for model railroad stuff, hopefully we'll be back to our regularly scheduled programming with the next video. Thanks a lot, guys.